learning about properties of bases. Getting it now? So talking about the taste and the touch of the bases. So we learned that bases have a bitter taste, right? And their solutions are soapy to touch. Getting it now? Furthermore, bases will be allowing the electricity to pass through it. They are also good conductors of electricity. Getting it now? Just like acids are good conductors of electricity, in the same manner, bases are also good conductors of electricity. Why? Because upon passing of electricity, the bases will break into the ions. They will break into charged particles. Thereby, they are good conductors of electricity. Yes, Abu Bakr, are you there in the class? You haven't been responding.
Yes, sir.
Yeah, turn your camera on in the class. Usually, you turn your camera off in the class.
Sir, 1 minute.
Hmm. Okay, yeah, this only you have joined. Usually, the students are not joining the class on given time. So talking about base, so far we learned about its taste and its bitter. We learned about its taste and its touch, and there are various things which we learned about it, right? Like the aqueous solution, the solution of the bases will be soapy in touch, right? Also, talking about the type of the test, like how do we test whether it is a conductor or not? Getting it? Now? I mean to say, how do we test whether it is a base or not? So basically, we will see that it will be changing the color of red litmus paper to blue. If I were to dip a red litmus paper into it, the color will change to blue. So that is another test to check whether it's a basic substance or not, right? And there are some bases which are soluble in water, while there are some which are not soluble in water. So the one that are soluble in water, they are called as alkali. Okay, na? They are called as alkali. Getting it right now? Furthermore, an important thing which I said that all the alkalis are bases, but all bases are not alkalis. What I'm saying that all alkali are bases, but all bases are not alkali. So let us understand what does this statement mean. In fact, we did discuss this in the previous class. See, there are only some bases which are soluble in water, so we call them as alkali. Okay, Fatima is here. It's it's already more than 10 minutes. Uh, it's already more than 10 minutes. Yes, Fatima, assalamu alaikum.
Walaikum Assalam, sir.
Okay, guys, please join the class on the given time now. Otherwise, you would be missing on important topics. Hmm? I urge everyone to please join the class on given time. Okay. What I was saying right now, what we were discussing in the class of Fatima. See now, what will happen? Other students will be joining in few. They will also take too much of time, and they will also be missing on important points. Hmm? Okay. See, the thing is that I was saying that in the previous class we learned about various properties of bases. Okay, Fatima, you also turn your camera on. We learned that they are bitter in taste and they have a soapy touch. They are slippery to touch. Right now, they will be turning the red litmus paper to blue. Right. Furthermore, we learned that there are some bases which are soluble in water and we call them as alkali. Okay, we call them as alkali. So all the alkali are bases actually. All the bases that are soluble in water, they are being called as alkali. So all the alkali are bases, but all the bases are not alkali. Why? Because all the bases are not soluble in water. So hence all the bases can't be called as alkali. Got this now, everyone? Both of you? Yes or no?
Yes, sir.
Good. Furthermore, we did learn about some special type of bases like limestone. We did learn about a calcium oxide also, that is quick lime. Okay, now we'd be revisiting those in a minute, but before that, let us learn about the type of bases. So we have strong bases and weak bases. Okay, now bases have been classified as strong and weak bases. Getting it? So talking about some of the strong bases, some of the common examples of strong bases are you have because Zunair is also here. We have example of lithium hydroxide is there, sodium hydroxide is there, or potassium hydroxide. Huh? or for example, you have rubidium hydroxide or cesium hydroxide. These are some of the strong bases which we have. Getting it? Just like we have learned that on the basis of strength, acids are of two types, strong acids or weak acids. Similarly, on the basis of the strength, also bases are of two types, namely strong and weak bases. Let me write down their names, and all of you would be required to memorize these names. At least memorize 3 to 4 examples of each type of bases. Okay. Yes, Zunaira, how are you?
So I'm good. Sorry for joining late. There were some issues with the Learnivio portal.
Okay, okay. Well, by the way, everyone is late today. All three of you haven't joined the class on given time. Okay, Abu Bakr was there on time, but you guys, you two, Fatima and Zunara, anyways. Then you have this sodium hydroxide. Right now, what am I writing, Fatima?
Sodium hydroxide.
Hmm. All these are the examples of weak or strong bases. These are strong bases, okay?
Okay.
Write this much. I'm
Sir,
going
can
to,
we write this down?
yeah, you guys can write down this one. Okay, no? I'm going to cancel these ones. These are not that much important. Instead of this, memorize this one. Calcium hydroxide. Calcium hydroxide, which we also call as slaked lime. Remember, this is also called as slaked lime, or we also call it as lime water. Also called as slaked lime or lime water. This is important. Remember this thing, that calcium hydroxide is also called as slaked lime or lime water. So these are some examples of the strong bases which we have. Getting it? Then we have certain examples of weak bases like NH4OH. It's not properly visible, but this is ammonium hydroxide. Okay, ammonium hydroxide. Ammonium hydroxide. Getting it now? We have examples of some other bases also, like for example, some other weak bases like take example of copper hydroxide. Copper hydroxide, this is a weak base. Or for example, you have zinc hydroxide also, that is also a weak base, zinc hydroxide. Okay, so what we will observe now, what we will observe, that the strong bases now, the strong bases, like when they are dissolved in water, they will be completely breaking up into the charged particles. They will be completely breaking into the charged particles. While when these bases are dissolved in water, like ammonium hydroxide, copper hydroxide, or zinc hydroxide, they do not completely break into the charged particles. What do I mean to say by this? Say, for example, I have taken a glass beaker and I have taken some base into this. Okay, now let's say this is any of the base from the above examples. And if I were to add some water into it now, okay, so thereby what will I will see? I will see that this base will break into the charged particles. Namely, for example, let's take a sodium hydroxide. For example, this is sodium hydroxide, which is a strong base, right? Sodium hydroxide. So this will 100% break down into sodium and, yes, Fatima, you were saying something?
Sir, we should not write the other
This
strong
one,
acid,
you
other
have to,
strong acid, because you
you,
covered them with the glass thing.
yeah, you don't have to write them. Okay, now the one which I have cancelled, you don't have to write. You just have to write this one. No need to write the formulas. Just focus on this: lithium hydroxide, sodium hydroxide, this, and these examples. Okay.
Okay, okay, sir.
Now I'm right now trying to explain on what basis they are being classified as strong or weak. Okay, now, so I will say just one simple statement like a strong base. A strong base will completely break. It will completely break into charged particles, while the weak bases Upon dissolving with water, it will not completely break into the charged particles. Is this a statement clear to everyone or not? Huh? Is this a statement clear right now? So for example, like this NaOH, it will completely break into Na plus and OH minus. These are the charged particles of it. What is it? How is it formed? No need to go in that much of depth. You'll be studying about that in later classes. Getting it now? What are these? These are charged particles. On top of their head, you can look at the positive and negative sign right now. Getting it? All of you would have studied about electricity, I believe. Any one of you who have studied about electricity?
Yes, sir.
So you might be
Six
having,
hours.
you have. Okay. By the way, why all of you have turned your cameras off in the class? Turn your cameras on in the class, all of you.
Yeah, internet
My camera isn't working.
got off.
Okay. Anyways. So what I'm saying that you would be having a slight idea about what charge particles are right now. Like for example, when you rub a plastic ruler on your hair and you bring it close to, you bring tiny pieces of paper close to that plastic ruler, so the tiny pieces of paper starts to get attracted to it. Why? Because it has developed some charge particles on it. Right now, well, namely, we have two kind of charge particles. One is positive, another one negative. The same thing is happening here. Like upon dissolving the base in water, if it is a strong base, it will 100% break into the charged particles. Nothing will be left. But in the case of weak base, what happens? Here, 100% breakdown is happening here. Okay, now let me write it over here. 100% breakdown into charged particles. Okay, now. Although in your exams, this wouldn't be asked in this much of depth, but you should have the clarity of the concepts. Okay, now thereby I'm telling you guys this thing. Okay. So in this one, let us say we have taken a weak base. Okay, give one example of weak base. Yes, you can take help from the above examples.
Ammonium hydroxide.
Ammonium hydroxide, good. Ammonium hydroxide. All of you make sure that you memorize at least two names of the strong and weak bases. Right after this, I will be asking about it from each and every one of you. So you have the time right now. Look at the names, at least memorize two of them. After 3-4 minutes, I will be asking. Okay.
Okay, sir.
So in this, what will happen? This will also break down, but not 100%. Let's say 30%, 40%, 50%, depending upon the type of base it is. Yes.
You would ask like name to strong acids or
Strong
name
base. Strong
base
base.
or weak base. You would ask like that.
Yeah, I will be asking like that. Okay, no? I can either ask strong or either I ask weak from you guys. Okay.
Sir, can you not remove this page? I'm still writing.
Okay, yeah, sure. I will not be removing it right now. So
Okay,
it
sir.
will break into charged particles. What those charged particles are going to be? It will be, in this case, it is ammonium hydroxide now. So it will be NH4 plus, and another one would be, I'm writing it over here, OH minus. These are the charged particles in which it is going to get broke down. But not 50%, not 100%. Like it could be like 30% or 40%, like that. So this is the criteria upon which how we classify them. Also, you guys think of this like which one of them will be more corrosive. Like bases are also known to be corrosive in nature. It can also eat the surface of the objects on which it will be placed. Yes, it will be. Which one of them will be more corrosive, more damaging? Obviously, they're strong bases now. You don't have to even think that much to such a simple question. So, okay, if everyone is done writing, please let me know.
No, sir.
Okay. Anyways, so I was saying that moments ago about the corrosive nature. So particularly some strong bases like sodium hydroxide, like this one, no? This sodium hydroxide or potassium hydroxide, these are corrosive, particularly corrosive toward the organic matter, like our skin. Huh? Getting it now? Like for example, if I were to, if this strong base, if I were to place it on my skin now for a longer time of period, for a longer duration, so what it will do is it will start to break down the protein found in the skin, protein found in the skin and the flesh. Getting it now? Got this? What I'm trying to say.
Yes, sir.
So it is corrosive in nature. Also, the action that it will have on my skin now, like it will make it make the flesh or the skin a pasty mass, like it will be a gummy mass, it will become a gummy and pasty mass. And this action of that acid now, particularly sodium hydroxide, that is NaOH, it is called as caustic action. And that's why this sodium hydroxide sometimes it is also called as caustic soda. What is another name of this? It's
Caustic soda.
caustic soda. So that is another name by which it is sometimes known as. So right next to sodium hydroxide, you guys write down this thing also, the caustic soda. Okay, hope everyone is done writing it. Okay. All right, I'm going to change the slide now. If anyone is still left to write, please let me know. All right. So let us start from Zunaira. Okay. Zunaira, you give 2 examples of strong bases.
Sodium hydroxide and potassium hydroxide.
Good. Abu Bakr, you give 2 examples of weak bases. Yes, Abu Bakr. Okay, moving on to Fatima then. Fatima, you give 2 examples of weak bases.
Copper hydroxide, zinc hydroxide.
Very good. Okay. Or ammonium hydroxide, that one can also be taken as example. Okay.
Yeah.
Yes, Abu Bakr, what happened? Did you noted it down? You could have answered by just looking at your note if you would have noted it. Okay. Anyways, next time be careful.
There are
Like
just 3 weak.
there are some more than 3 examples. I have just given 3 of them. Okay, no. There are several weak bases. No need to memorize that much of. Like you have zinc hydroxide, you have chromium hydroxide is there. Okay, no. Anyways, then we were learning about uses of bases, right? We did learn about this water, the uses. Some of the common uses, like it is used in the manufacture of certain kind of bases are used in manufacture of cement. Some is used in making toothpaste, manufacture of paper, used in the baking industry. Which base is used in the baking industry?
Sodium bicarbonate.
Sodium bicarbonate. Very good. Also called as baking
Baking soda.
Baking soda.
All right. Certain type of bases are used in whitewashing also right now. Okay. While there are certain kind of bases which are usually available in the laboratory. If you happen to have a chemistry laboratory in your school, you'd be most commonly finding these bases, right? Okay. Let's see if you guys can identify which one of them is strong or weak here. Okay. This ammonium hydroxide, is it a strong or weak?
Weak. Weak, sir.
Weak. Calcium hydroxide?
Strong.
Strong. What's the another name for this?
Lime watery.
Lime butter.
Or salted lime.
No,
Slate.
slaked lime.
Oh yeah.
Slaked lime. Okay. Potassium hydroxide?
Strong.
Strong. Sodium hydroxide?
Strong.
So, and note down that this is also being called as caustic soda. The
Caustic
reason I
soda.
explained why it is being called so, right? Okay. Furthermore, this magnesium hydroxide. As a kid, sometime you would have been given this medicine, I believe. Okay, now milk of magnesia. When someone suffers from indigestion or suffering from acidity, in such a case, this milk of magnesia is given. And by the way, milk of magnesia usually it's a weak base. Okay. So these are some of the bases that are used to carry out various experiments in laboratory. I have just given you a few examples, although there are many more bases that are available in laboratory anyways. Now, if you guys remember, we were learning about the quick lime in the previous class, right? That is calcium oxide. Calcium oxide. Okay, now that is CaO. The formula is CaO. By the way, this calcium oxide or quick lime, it is obtained from limestone. Okay, na? This is obtained from limestone. Okay, so by heating limestone, what happens when we heat the limestone now? So the calcium carbonate, upon heating, it breaks into calcium oxide plus carbon dioxide. So this is how it is obtained. Okay, now by heating this sedimentary stone, when it is heated, so then calcium oxide, that is lime, is obtained. Okay, let us understand how it is prepared. Like now, from this calcium oxide, lime water is prepared. From this quick lime, that is calcium oxide, lime water is prepared. Getting it now what I'm saying? So we are going to learn how it is prepared. So all of you have a look at this video. Let me just slightly reduce the sound. Okay, do let me know if it's audible or not. Okay, if it's not, just raise your hand in the class. So in this, quick lime has been taken and water has been added in this. Just some more water has been added, and at this moment, what has happened? The calcium oxide has started to react with water. Calcium oxide, that is quick lime, has started to react with water. Okay, and the product that will be formed is calcium hydroxide. This calcium hydroxide is basically, yes, that is basically, yes. You should be able to answer this. I think moments ago we have learned this now. In the previous class also we did learn about this one. This is basically lime water or slaked lime now.
Yes.
Huh? Okay, now look at it further. Okay, some more water has been added in this. And you guys can see like a smoke coming out of it. Powder and a smoke coming out of it. And if you were to observe it, bubbles are also forming in this. Now just look at this. A little bit of explosion. So one must cover their face with a protection glass or a mask. Notice how bubbles are forming.
Yes.
So now you have slaked lime. Okay, na? So the product that we will be having at the end is this paste that you see now. That is basically calcium hydroxide or slaked lime. So hope this is clear to everyone. And this is what basically happened. If I were to sum it up, have a look at this. We took the calcium oxide, that is quick lime. We added some water, and then we got slaked lime. Now in this, heat was also given out. So this is how lime water or slaked lime is prepared. Okay, what is the use of this slaked lime? Where is it used? Yes. What's the use of lime water? Yeah, Zunaira, didn't we learn about this in the previous class? Fatima, Abu Bakr?
Yes, sir. It helps in the production of cement to increase the quality of soil.
Okay, to increase the quality of soil,
It's
but
also used in toothpaste.
toothpaste, and one of the toothpaste there, limestone is particularly used. Okay, one of the most common use of lime water is it is used in
Paint.
whitewash. Whitewash, not in the paints usually, in the whitewash. Getting it now? Okay, so here we have completed this topic. Now we are moving on to the next part of the chapter. That now we are going
That's
to
the
learn about.
last.
Yes.
That's the last topic of this chapter, the one that we are gonna learn
Yeah,
now.
one of the major topic I would say, because there are still few things that we'd be learning. Like we have to learn in detail about few things. Okay, now some things are left. Now after this, you have salts also. So second last topic you can say. So talking about neutralization reaction now. Like whenever an acid or a basic substance would be reacting with each other, so both of them would be canceling out their properties. Each of them will be canceling out their property. So the end result that you will be having will neither have property of an acid or nor having a property of base. It will be a neutral substance. That's why the reaction that takes place between acid and base is being called as a neutralization reaction, because both the reacting substances like acid and base, their properties are being neutralized right now. So here what we can see, like we have taken some acid. For example, just look at it right now. So we have taken this base, that is sodium hydroxide. We have taken some acid, that is hydrochloric acid. Now both of them are going to react, and the end product that you'll be getting now would be water and salt. We have an acid, that is hydrochloric acid. We have a base, that is a sodium hydroxide base, and in the end result we get water and a salt. Getting it now? So the product, that is this salt, it doesn't have property related to acid or that to base. It's a neutral substance. Okay, so the nature of the acids and bases are destroyed in this reaction. Okay, and this example that you see, this is one of the most common example of a neutralization reaction. So hope this topic is clear, that what neutralization reaction is, right?
Yes, sir.
Yes.
Okay. Now later on we will get to know that here we guys know that acids can be strong and it can be weak. Bases can be strong and it can be weak right now. So what if a strong acid is reacting with a strong base? What will happen? What kind of salt will be formed? Listen carefully to what I'm saying. What if a strong acid is reacting to a weak base? What will happen in that case? Or what if a weak acid is reacting with a strong base? Or what if both of them are weak in nature? Acid is weak and base is also weak. So then what kind of salt is formed will be formed? So that thing we will be learning after a few minutes. Probably after 10 minutes, we would be touching that topic. Getting it now what I've been trying to say?
Yes, sir.
Right now, we are going to learn about the neutralization in our daily life. Right now. So that is what we are going to learn right now. Okay. Okay, one of you please read the
Can I read,
first
sir?
two paragraphs. Yeah, sure.
Can I?
Yeah,
During
sure.
indigestion of taking milk of magnesium hydroxide gives us a relief as it neutralizes the effect of excess and acid produced inside the stomach. The effect of ant sting, which is caused by formic acid, can be neutralized by rubbing moist baking soda, basic in nature.
Continue.
To ensure the plants can grow well, the soil is treated with either acids or bases, depending if it's basic or acidic in nature. Factory waste generally acidic in nature and can cause environmental damage are treated with basic substances before discharge.
Very good. Okay. So see, it is observed in the nation now, like whether it be the digestion taking place in our stomach, whether it be the growth of the crops in the soil, or whether it be the fishes that are in the water bodies. all of them would be nourishing well, all of them would be comfortably living in comfortably living, huh? Or the process of digestion would be comfortably taking place if the pH level is maintained to neutral. If the medium is neither acidic nor basic, but it's neutral, so then what happens? It will be happening in a comfortable state. Getting it now? Like, it's a common observation that if the pH of the soil were to increase from 7, or if it were to decrease from 7, okay, na? Like if it increases to 11, so the soil will be highly basic in nature. If it increases to 11 or 12 or 13 or 14, that soil will be very basic in nature and it will not be fit for cultivation of crops. Or if the soil is very acidic, like it has a pH value of either 0, 1, 2, 3, 4, 5, or 6. So in that case also the soil will be said to be acidic and the crops will not be able to flourish well in this. Why? Because we know that there are various kind of living organisms, certain kind of microbes, certain kind of insects and worms are found to be living in the soil, which are beneficial for the health of the soil. They increases aeration in the soil. They adds organic matter to the soil and thereby increases the humus of the soil. So if the pH level is disturbed, if it is too much acidic or basic in nature, so thereby they will not be able to survive, they will die. Hence the quality of soil will go down. It will be losing its fertility. That's why a farmer who is well educated, well informed, he would be first of all checking the pH level of the soil before planting the crops. Getting it now? Or why do we suffer from indigestion certain times? Like whenever you guys would be eating lots of fast food, junk foods, particularly fast food is a different thing, but particularly when you eat lots of junk foods now, lots of oily food that contains saturated fat in it. So it triggers your stomach to release much more amount of acids. Getting it now? So in that case, what is happening? Your stomach is releasing too much of acid. Like if we are suffering from indigestion, let's say, or we are suffering from acidity, huh? So you guys observe here, like this is a acid. Okay, no? Too much of acid is being secreted by the inner lining of your stomach, right? And sometimes this acid can this over secretion of acid, what have happened? Yeah, over secretion of acid can lead to acid reflux. Acid reflux, I mean to say, in which the acid will go into the food pipe, that is the esophagus. Right now, that's why sometimes you would be having like the you would have observed this thing, like if you have eaten lots of junk food, sometimes the kind of acidic saliva will come in your mouth, acidic fluid will come in your mouth, huh? Maybe you would have sometime it would have happened with you guys. So that is basically the acidic substance coming all the way from your mouth, no, from the stomach. Is this thing clear to everyone?
Yes, sir.
Right? Okay. Furthermore, when you take an antacid, right, when you take some antacids, so then it will neutralize the effect of the acid. A neutralization reaction will be taking place here. Getting it, guys? So here, say you have taken an antacid. Antacid is a basically, it's a basic substance, okay? And here is the HCl. So HCl plus the base, so thereby it will lead to neutralization. That is how acidity or indigestion is cured. Hope that is clear to everyone. So during indigestion, particularly milk of magnesia, which is a base, it is taken. It neutralizes the effect of excess amount of acid produced in our stomach, thereby giving us relief. Furthermore, the effect of anthisting. The anthisting contains which acid?
Formic acid.
Formic acid, right? Okay, so it can be neutralized by rubbing moist baking soda. Okay, now? So you take some baking soda, just rub on the skin, you will get relief from it. Why I have to take a moist baking soda? Because the basis shows its effect only when it will be dissolved in water. Okay, now? Otherwise, usually it will not be working, right? Furthermore, to ensure the proper growth of plants, the pH level has to be maintained right now. So if it is too acidic, so basic substances will be added in this. For example, if the pH level is like 2, 3, or 4, so then what the farmers would be doing, they would be adding quicklime to neutralize the acidic soil. This substance that you see over now, this will be added. Getting it, everyone now? That is how we can do so. Okay. Now, furthermore, you guys answer this thing to me. You think of this logically and answer. What should be added to the soil if its pH level increases to 11? Like it becomes basic. Just go on. Guess I'm audible and visible to everyone. Yes, Fatima, Zunaira, Abu Bakr. I must have to add some basic material into this now. Or should I not? I mean to say, I should be adding a acidic material now in
Yes,
order to
Yes,
in
sir.
order to bring down
should
the
we add
pH level.
sodium hydroxide?
Sodium
Can
hydroxide?
we-
No. Why would be adding sodium hydroxide? Sodium hydroxide is already a basic substance. Now, I am saying if the pH level had increased from 7, like 10, 11, or 12, so that means it's a basics. The pH is basic now. The nature of the soil is basic. Getting it now? So can addition of manures bring down the pH level? Think about this.
So yes.
In certain cases, it can bring down. Getting it now? In certain cases, it can bring down. Well, usually it is not used, by the way. Okay, now usually sulfur would be added. Okay, now if the pH level is too much, like if the soil is basic in nature, so sulfur will be added to bring down the pH level. So hope that is clear. So in this, write down two things. Like for example, to make soil basic, acidic substances are added. I mean to say, to make soil neutral, to make soil neutral, acidic substances are added. When we'll be adding acidic substances? If the soil is basic. Getting it now? If soil is basic in nature, so thereby add acidic substances, the both of them would be reacting, neutralization reaction will take place, hence the pH level will be restored to 7. Okay now? Or otherwise, if we have to make soil neutral, basic substances are added if soil is acidic in nature. Hope this is clear to everyone.
Yes, sir.
Good. Furthermore, we know that factory waste that would also contain too much of acids in this. Usually they are acidic in nature. So if they are dumped directly into the water bodies like a lake or a river, so it will be killing the fishes, killing the aquatic plants, right? And lots of aquatic plants grow, like water lily or lotus or kelp. They are the aquatic plants that grow in the water, right? And they are important for the ecosystem of the water body. Many of them are food for the fishes. Like the fishes would be eating some aquatic plants, right now. So the pH level of the water body will be disturbed. Hence, fishes will start to die. Getting it now? That will happen. Also, you would have observed this thing. Like if you happen to visit a place where the water body is very much polluted now, so you will see a green carpet like layer would be visible on the water body. It will look like if someone have laid a green carpet over the water body, but it's actually alga growing on the water body. Have you guys seen that, what I'm saying? That is in fact called as algal bloom. See, let me show you what I'm saying. This is what I'm talking about. See, this is a polluted water body. Okay, now this is a polluted water body where you get to see that from a distance it will appear if someone has laid a green carpet over the water body. What happens from the factory, different wastes are being dumped into the water body, right? It could be different kind of chemical substances, obviously. So that chemical substances will be nutrients for alga. For alga. Alga, you guys know what are alga? You would have seen like near the tap now, near the tap water, alga can be found to be growing. Those greeny patches that you see growing wherever some moisture will be available, that is what alga is. Okay, now. So the nutrients, like the waste coming from the factory, will be kind of nutrients for the alga. So when too much of nutrient would be available to them, so their quantity will increase and they will grow in such amount that it will basically cover the surface of water body, and thereby it will block the sunlight to reach into the water body, and hence the aquatic plants will die. Also, they will uh, they will absorb too much amount of dissolved oxygen from the water, hence content of oxygen, amount of oxygen in the water will decrease, hence fishes will start to die. And is this is called as algal bloom. Is this thing clear to everyone?
Yes, sir.
Good then. Okay. You guys answer these two questions.
So in the chat box, right?
You're in the chat box. On this side, answer it quickly, by the way. The question, this is question number 1, this is question number 2. Yes, that is correct. Yes, Sonara, that's correct. Yes, Abu Bakr, you haven't been answering. What is the primary component of antacids? So answer this one also. Although all of them are bases, but not all of them are used to prepare antacids. Antacids, you guys are getting it now. Basically, they are kind of medicines that gives you relief from acidity or from indigestion. So that is what are antacids.
Sir,
No,
are my answers correct?
no, Fatima, that isn't correct. Abu Bakr, for which question you have answered option C? For the first one, no. No, your first answer is correct,
No,
but
sir,
second
for
answer
the
is correct.
second.
For the second one, you have answered C. No, no, you guys aren't getting it. You guys are not getting it. Okay, see.
The first is
Okay, for the first one, C, it is correct. No, no, you guys just have a look at this once again. See, this milk of magnesia now, talking about milk of magnesia, while we were learning about uses of the bases now, that you guys forget to note down this thing. Remember this magnesium hydroxide? This is commonly called as milk of magnesia, and this is used as an antacid to control acidity. Okay, now it neutralizes the acid. Neutralization reaction takes place in the stomach when we take milk of magnesia. So this is actually magnesium hydroxide, which is commonly called as milk of magnesia. So this is used to prepare antacids. Got this now, all three of you? The correct option is option number A. In fact, both of the questions are really, both of them have the same answer. Getting it? Okay, now talking about neutral substances. So neutral substance would be any substance that will neither be acidic in nature, will not be basic in nature. Furthermore, it will be having a pH value 7. Okay, now like we have water, we have table salt, sugar solution, cooking oil. All these are some of the common examples of neutral substances. Getting it? Okay. Now we are going to talk about salt. Right now. So as we know that salts will be, by the way, of different types. There are different types of salts. Right now, there are different types of salts. Some of them are edible salts. Some of them like we have rock salts are there. Getting it now? You will have seen like some rock salts are there. You have pink salt. Himalayan pink salt is very common, by the way. So although their salt can occur naturally also, while some of the salts can be prepared in the laboratory also. Getting it now? On the basis of occurrence, salts will be of namely two types. Getting it? On the basis of occurrence, one that will be found in the nature, one that will be prepared in the laboratory. So usually we are saying that it's a product formed from the neutralization reaction of acids and bases. Getting it? In the nature also, the different kind of salts that we see now, like the rocky salts that we see, certain kind of rocks or certain kind of rocks are salts right now. They're also formed because of neutralization reaction only, right now. So it's a product obtained after neutralization reaction having taken place between acid and base. Have a look at this reaction where you have hydrochloric acid and sodium hydroxide. The reaction takes place between them, and the product obtained is salt, that is the table salt, and water, that is H2. Also, this salt, it's one of the most common ingredient that we use in different food items right now. Or the reason why we call this as common salt, because it is consumed on a daily basis in almost different kind of food items. It is added. Furthermore, you guys answer this to me, like why our body requires salt? Does our body really require salt? Or is it really important for our body to have salt?
Sir, you should just not consume a lot of salt. Salt
We should not.
like-
We should not consume a lot of salt, but in a regulated and a minimum, small amount of salt is important.
Yeah.
Right now, because it is important for the proper functioning of the nerves, or in order to control the blood pressure, or to keep our muscles working properly, a small amount of salt is necessary. Right now, also
Yeah.
salts contain iodine in it also, and if
Yeah.
some kind of salts does not contain iodine, so then iodine is added into this. So salts are usually the source of iodine for our body, right? And we have a gland in our neck, in our throat, called as thyroid gland right now. And thyroid gland will function properly if it gets adequate amount of iodine. Have you guys ever seen such people like whose necks would be really swollen? Have you seen people who would be suffering from a condition called as goiter, that is a deficiency disease? Yes, none of you. I mean to ask, like, do you know
Sir,
about
I've
goiter?
heard of it,
Yes,
but
sir.
I don't know.
Okay. Maybe I can get that image. Okay, anyways, it's not here. Basically, in that case, what will happen now? Like, this is a person, for example. So their neck would be really swollen like this. Their neck would be really swollen like this. So there, what basically has happened now? Basically, what has happened? Why their neck is swollen? Because there's a gland in their neck. There's a gland in their neck. Okay, there's a gland in their neck. That is the thyroid gland. Okay, but if this gland is not getting adequate amount of iodine, so it can swell and the size can increase Hence, the neck region, the throat will appear as swollen. Got this now? So thereby salt is important. So salt is an important source of iodine for the body. This iodine, it is essential for proper functioning of thyroid. So it is required by thyroid gland, by the thyroid gland. Getting it now? Furthermore, talking about some other functions now, like some of the other functions. So proper functioning of our nerve. Okay, na? So proper functioning of nerves, proper functioning of nerves, muscles, and maintain the fluid in the body and maintain the fluid content in our body. Our body, it is important. It is important. Another thing is now, like it regulates the blood pressure of the body also. That's why you see that people whose blood pressure is low, he will be advised to take a small amount of salt. If their blood pressure is high, so the doctor will advise them to not consume too much of salt. Getting it now? So salt helps to control blood pressure. Getting it now? Why? Because the salt contains sodium in it now, like this common salt, it contains sodium in it, isn't it? It contains sodium and it contains chlorine also. So sodium in your body has got various role to play. Right now, our body requires sodium for our muscles and for our nerves to work properly. Got this now? While there are some side effects of salt also, like high consumption of salt can lead to high blood pressure in some people. Okay, now in certain cases, it can even lead to kidney or heart failure if people consumes it unusually in high amount. Okay, so regulates blood pressure. So is this much clear to everyone so far?
Yes, sir.
Yes, sir.
Okay, then that's it for today. In the next class, let me just tell you what are the topics we're going to learn. We'll be learning about types of salts. Remember, moments ago I told you that what if weak base or a weak acid reacts? What if a strong acid but a weak base reacts? So in that case, what kind of salt will be formed? We'll be doing